Oops, I'm so sorry. I think I mute myself. Okay, hi everyone. Okay, welcome to Google Developer Chase channel, and thank you all for tuning in to the session tonight. Yeah. So today we have Data Engineering Singapore again. Yeah. So really thank you Teck Chun and Ravindra for organizing all these monthly events and then bringing all this great speakers on board and to tell us all the know-how about data engineering. Yeah. So okay, before we begin, right? So I would like to actually briefly introduce who we are and what we do. So Google Developer Space is a platform for developers and startup around the region, okay, to learn, connect, and engage and be inspired. So I'm Lawrence from Google Developer Relations team. Yeah. So if you actually like our channel and you like all the content that we bring to the table, please follow us on our website, okay, our Facebook page, and our YouTube channel. Please subscribe them so that you can get the latest updates. Yeah. Okay, so Data Engineering Singapore. So it's actually a community for data engineering to share the know-how and on all the things related to data engineering. Yeah. So I'll let Teck Chun to briefly tell you more so that more engineers should join can join. Teck Chun, let me add you in. Hi Teck Chun.
Hi, thank you. Let me add my co-organizer, Ravindra here as well. Yeah.
Yep.
Hello, hi,
Thank
good evening, and welcome back again for this edition. Last month we didn't have any meetup, so we took a break, a short break, and this month we are back with an online meetup. I so good to see all of y'all again, and thank you to Lawrence and the Google Relations team for having us and helping us with this online streaming as well. Yeah. Thanks also Lawrence for the introduction. Yes, if you are not aware of the meetup group that we are hosting here, it is Data Engineering Singapore, and you can scan the QR code, which will take you to the meetup group, and we hope to see all of you out there. And we aspire to host a meetup every month. We are always looking for speakers. Hopefully, you can join us on this journey to share your knowledge. Okay, I think today we have one speaker lineup, Jason. Let me add him to the channel. Yeah. Hi, Jason.
Hi, Teck Chun.
Hi.
Hi,
Yeah.
Lawrence, Ravindra.
Hello. Hi.
Hi.
Yes. Hi.
Hi.
Yeah. Jason is a staff solutions engineer from Confluent, and today he has an interesting topic to share with us uh, on the 5 challenges of data processing and why Kafka can help us. Right. Right. But before we share that, maybe just understand a bit about your background, Jason, and some motivation for today's talk. Maybe tell us about yourself and in your day job a bit.
Yeah. Thanks, Teck Chun.
Yeah.
Yeah, so like you mentioned, I'm born and bred in Singapore. Spent a bit of time in Australia for a few years, working there and also studying there. Came back recently, about 2.5 years ago, slightly before the pandemic.
Okay.
Uh, I my background is more on the monitoring, SRE, and observability space. Recently just transitioned to Confluent, um, where because when I was in that space, I saw a lot of challenges with data processing and no slow
Okay.
applications, and I saw how Confluent and Kafka specifically, there's quite a number of challenges, right? But a lot of people
Okay.
didn't know about it. So that's where what brought me to Confluent. So yeah,
See. Okay.
yeah.
Okay. All right. All right. You spoke about a bit of what motivated you for this talk. You saw some gaps in data processing
Yeah,
and how Kafka could help.
yeah, that's
What
right.
what other things motivated you for this particular talk? I mean, amongst other topics, why this one stand out for you? Yeah.
Yeah, I think it's short, it's sweet. It's five key challenges, and some of these challenges bother me as well today. Like when I interact with other systems, or I'll share with you later on some of the things that really annoy me, and start to think about from a data side, like what's happening in the background. When these things are not working, and try to figure out and a lot of the conversations that we are having with our customers as well is very similar to these types of challenges, right? So these are challenges a lot of people in the industry are also facing. And sometimes it's a mindset shift. So I'm very happy to come here and share with people today, right? Some of these challenges and have look at things a different way. Yeah.
Okay, sounds good. That's exciting. Yeah, okay. Maybe not to hold you back from your exciting talk. Maybe you want to, it's a screen share already, Lawrence, is the slide or how should I?
No, Jason, you could share your screen.
Yeah, okay.
Okay. Yep. Can everyone? Is it okay?
Yeah. Yes.
Okay.
Okay.
Yep.
Without further ado, I'll hand over the stage to you, Jason. I'll see you back in
Yeah.
a while. Yeah.
Thanks, Teck Chun. Yeah.
Yeah.
Yeah. So like Teck Chun mentioned, like the talk I'm sharing with you today is the 5 processing challenges and how Kafka helps. My name is Jason, based in Singapore, with Confluent. Just a bit about me, like born and bred in Singapore. Went to Ngee Poly and then into UQ a few years, actually more than 15, 20 years ago. I stayed a while in Brisbane, then I went back to Brisbane and worked. So I handled a lot of like state government and federal government in Australia for a while. Then I got a bit bored. Then came back to Singapore, right? And while I was in Brisbane, also, I was a bit bored. I attended a lot of meetup as well. So I really enjoyed the community, especially meeting face to face with everyone. And I attended, I think, the DevOps meetup, the JavaScript meetup in Brisbane. It was a very good community, and I had a very good experience there. So hopefully we can meet face to face again, in Singapore. That would be good. And one thing we always had at the meetups in Australia was pizza. So I got my pizza here and my beer, right? So uh, it was always like, maybe someone would sponsor pizza and beer, and we would always like talk about some of the challenges. And that was where I learned a lot about the newer stuff, right? Because in my job at that time was handling with more of the legacy systems and the on-prem, and I learned a lot about the cloud and DevOps and CI/CD just by attending the meetups and asking people and getting a lot of information. Right? So those meetups really helped me. And when I came back to Singapore, I also started the meetup, but it was during the pandemic. It's very hard to get people to meet up in the pandemic, and virtual events for some reason doesn't really work well for me, and it's still not so interactive when it's starting the new. But it's really great community that Teck Chun has built, like here, especially with the organizers for the data engineering meetup. Yeah, so without further ado, let me go into the core of this topic, right? Yeah, so like I mentioned, I was working with a lot of the legacy banks and governments and large organizations, and I was attending meetups to learn about the new way of doing things. So I could see the contrast of the two different things, right, and how they were addressing the problems, right? So obviously slow and fast, batch processing, right? A lot of organizations still have batch jobs. Some of them are quite relevant, but a lot of them are just maybe for reports or just ETL batch jobs. And if a batch doesn't run, then all hell breaks loose, and the people have to go and do some data patching, right? And now with Confluent, we do real-time stream processing. And so that's really a fundamental change in the way of doing things, right? And from siloed systems, single data stores to more connected, right? Everything is more connected and integrated well together. And so there's a shift that's happening. It's happening slowly across different paradigms, but I think now we're a lot more on the new way. A lot of organizations have been adopting a lot of the fast-paced, especially digital natives. They are really fast in adopting all these technologies, right? Like I mentioned with Teck Chun, like what motivated me for this talk. We have all this technology in the back end, but I still get WhatsApp, spam. Sometimes I get added to a group in the back out of nowhere, and then people start leaving. I still get the classic 5 scam calls, right? Even you report, nothing happens. Like recently, I get quite a lot of this iMessage spam, right? And I keep deleting and reporting, but nothing happens, right? And it turns out that fraud detection is a big problem, right? Even companies like Grab or Gojek and all the ride-hailing companies, and fraud is uh all those especially digital native, they face fraud as a big challenge, right? And why can't they solve this problem? Like, why is it so hard to detect suspicious networks, right? This is essentially what you're looking at, right? If 5 people report the group in a row, that should sort of trigger something and like block something, right? I mean, why? And like if the spam caller is making 5 or 10 spam calls and people are reporting, surely there should be something in the background that can automatically block these people. So I started thinking, and when we look at the way people are processing data, like it's usually SQL or relational databases, or depending on the systems of how they're designed, right? It's all relationship based or document based. And it's very hard to do this real-time processing and aggregation on the fly. So this is one of the challenges. And I started thinking about how people could solve this, especially fraud detection. Right, some of the challenges that we work with our customers as well. Right, one potential solution is if you look at a lot of the fraud, it's basically it's all based on networks, right? Like some sort of graph table, right? So potentially linking up Kafka with real-time data. So as every transaction is flowing, right, every record is coming, you're building that graph, right? And the way to think about graph is like the way your brain is wired, right? Like a neural network, right? You've got all these interconnections instead of just a table, right? As you can see, so you can see that, oh, maybe certain behavior is happening in certain clusters, right? As they started to build up, then you can get some alerts and notifications, right? So these are some of the cutting edge technologies, right? That Neo4j, Tiger Graph, and Kafka. I'm sure you all know Kafka as a data streaming platform, right? Streaming data in. So combining these two, I mean, it's just a thought, potentially could solve a lot of scam cases, right? I think recently there was a bank, I think a bank that there was a scammer scamming all the people with fake SMSs, and they click on the link and they start going in, but for some reason the bank couldn't really detect this in real time. Like why couldn't they stop it or detect it? And even after the incident happened, they had to spend quite a number of time to comb through their data just to find these suspicious networks, right? Yeah, so this is something that I think would start to see a lot of traction, right? As people start to fundamentally change the way of thinking and start to think about graphs. It could be one way where you can apply it to different use cases as well, right? Not just fraud detection. Yeah. Yeah. Next challenge, right? I mean, I'm sure we've all encountered this, right? Slow reporting, like especially in the on-prem environments where there will be a job that will run at the end of the month. It will run a huge SQL query, and it's running, and the main challenge when you're in that environment, you say, hey, the SQL query is running slow. Oh, maybe the index is not built, and then they'll go and rebuild the index, right? So those large queries and slow reporting, that's another thing that bothers me, right? And when I was managing like an on-premise product with a SQL database, it was a very common issue, right? When the reports don't come out on time, and the only solution was to scale it out horizontally, add more nodes to the database. But if you look at, you fundamentally change the way you're thinking and think about it as events, not as data sets. So every event, you're updating that view or your report, right? So as the events come in, you're constantly updating that report, right? That's what Kafka can help you do as well. Right? You're streaming the events changes, and as the changes happens, you update that. Then there's no waiting time, right? For the report, right? It's there when you need it, right? You just have to figure out what you want to see, and then get the data at the right time, right? Yeah, so these are some of the challenges, right? And even with a lot of companies today, they still can't move from a lot of the old way to the new way because there are a lot of dependencies involved as well, right? With these large queries and reporting, and a lot of the architecture is built on around that. Yeah, so these are one of the challenges that I see happening. Yep. Next question, yeah. So slow ETL, right? So how it starts is someone has a database, they've got lots of different data sets inside. And this could even be a cloud database, right? But they put all the data inside it, and then they want to get an analysis, so they run the reports, and these are quite heavy duty reports on the same database, and it creates some performance issues, right? So they come up with the idea that, hey, let's put it out. We'll have a separate database. We'll have a job that will move, like an ETL job, to move data to these different databases and data stores, right? Maybe move it to the cloud with Snowflake, MongoDB, and those types of data warehousing solutions. But they end up with different data sources, right? And sometimes moving this data becomes a challenge, right? So you may have solved one problem, but you have created like a spider web of issue, right? And so this is where Kafka plays quite well in getting the data from disparate data sources and putting it into where it needs to be. The key thing is not so much of the event driven and the speed, right? Although that's an advantage, but the key thing is the decoupling, right? Because if you look over here, right, it's all these one-to-one relationships, and having to set that up and configure all those one-to-one relationships and maintain that structure, right? It's quite challenged, right? Especially if you look at a lot of the organizations where a lot of them are all interconnected. It's like a spaghetti bowl altogether. With Kafka, it really simplifies it and sort of decouples the systems from each other, right? So if you want to add a new system that taps into the ratings data, right, you can just tap it to Kafka, and you can get that data in, right? And you can do your analysis. If you want to put that data back in, you can put it back in as well. So the decoupling really is a huge benefit. And obviously it's a lot faster, right? When you're streaming the events from the various systems. Yep. I think I'll answer a lot of the questions at the end of the talk. So I think me and Teck Chun will have a separate Q&A session. So if you got any questions, just type it in the chat or raise it up later, and I will be able to answer some of the questions you might have. Yeah, moving on. Yeah, wait. This is 3. Yeah, this is 4. Yep. So here comes everyone, right? So this is 4, challenge 4, right? So everyone is coming. Everyone, has a device, and there's a lot of data that's happening. And what a lot of a big data challenge here is to get a profile of the customer, right? Because in my previous challenge, the data now is at all different places, right? You've got all the data in a different place, in different stores. And then you say, hey, wait, I want a single view of my customer, right? If they buy something from my store, or they go into my store and buy something, or they talk to support, or they post on Twitter. You want to know, people want to know much more about the customer. And the challenge is that all these systems, all this data is in different systems, and it's very hard to bring them together, right? So that's challenge 4, right? And this how Kafka can help, right? And this is not just Kafka together with CDC, so change data capture. If you're not familiar with change data capture, it is basically instead of doing normal batch-based ETLs, CDC typically will look at the transaction log of the database, right? So as the data changes, you slim the data changes, the delta changes. If it works well, it works well, but sometimes there are challenges with CDC as well. right? Maybe the timestamp is not in the right format, or the transactions do not even up correctly. You may have some challenges with CDC, right? But overall, the way it works, right, is quite beautiful once you set it up, right? The Oracle or SQL databases, as the data comes in, it slowly streams all the events to a Kafka topic, and that data can go anywhere. Right. So having multiple data sources, you can have CDCs, you can have Kafka, you can have a ETL job if you want, like send it into a Kafka stream, and you can capture customer transactions, and from different sources. So in this place, I got customer details and the transaction details, and then two different tables, right? And with KSQL DB, so that runs on top of Kafka, right? We are able to merge it into one view, like a materialized view. So that's very powerful, right? If you have data from different sources about your customer, you can merge it together into a materialized view, and it's always updating, right? It's a live view of the customer profile, right? At Confluent, we call it customer 360 or C360. So this comes out of the challenge for Lead to have a single customer profile, right? Because once you build up that profile, you can do a lot of things. You can know, like, okay, maybe this profile, this user, WhatsApp user, has been constantly creating groups and adding people, right? And you know, okay, maybe what type of device is on, or some details about him, so you know how to block him later on. Or maybe this specific IP address has always been doing something, right? So it really does help and unlock a lot of possibilities by having that single consolidated view of the customer, and Kafka really plays a key role in helping doing that, right? Instead of the other way is to build APIs all over the place and run jobs to post data to the different systems, and that becomes really challenging. Yeah, so that challenge 4. Yeah, challenge 5. Yeah, so first, here comes everyone, then now here comes everything, right? So this is another big challenge, right, that I see happening, like, more and more use cases of this, where it's IoT and devices from everywhere, like the train, the bus, from drones, anything that you can put a 5G connection, so it's going to be connected to the internet, right? And then you want to get hundreds of various data points like temperature, sensor, location from all these various devices, right? It could be a cargo ship, it could be anything. And so this is a huge challenge, right? With all these large data sets coming in, right? Imagine if you want to put that on your traditional relational database, right? On a single database, like with all this massive amounts of data, like would you do that? Like, yeah. So that's a really big challenge, right? And Confluent does Kafka is really designed for handling large volumes of data, right? So this is a good use case for us, where we can get large amounts of data in, and the only challenge is where do we put it? Like, you have to have a very uh, fast-paced data store where we can store all those data in if we need to, or we can do aggregation within Confluent itself, where stream processing, track and trace, like, even like your delivery rider, as they go to different locations and send out the parcels of goods, like all the data as they are delivering is being tracked, right? So that you can see the status of your parcel, right? You can say, oh, your parcel is arriving in 5 minutes. You get a notification. All that is event driven, and most likely is Kafka, right? In the background, like when you order from Grab, when you look at all those like cars moving, a lot of it is all event driven, to be able to get that type of data, right? And you can't simply store that type of data in the database and run a select query constantly to pull that data out. Like, you have to really change the way you think about it, right? And that's where Confluent comes in. So one of the approach that we have, this is an example architecture for billions of events. MQTT, I'm not sure if a lot of you are familiar with, is similar to Kafka, but it doesn't have persistence and it's more lightweight. And that's used amongst IoT devices, right? So a lot of the devices that you see here, all these devices, typically they will use MQTT or some other lightweight messaging protocol. And that works really well with Kafka. We can stream that data in. We've got connectors, they can put the data in. It's all similar type of concept. And in the Kafka, it's more persistent. So we can run stream processing on the fly and do some calculation or send it to BigQuery, Snowflake, or MongoDB type of databases. And then you add can read from it, right? So that's that's one example. I think almost come to the end of the 5 challenges, right? So having Kafka with MQTT and a bit of observability, right? There's a lot of potential out there with data processing, like where you got, they call it IIoT, like Industrial Internet of Things, right? So it's no longer my house smart light bulb, right? It's every industrial device out there is going to be connected to some network, right? And they're going to be sending a lot of data, ingesting it. These are some example data flows that we built in Confluent, where we can stream it accordingly. And this is some of the challenges that we are working on as well, right, with Kafka. So I've come to the end a bit early, but maybe any questions so far?
Thanks, Jason, for the presentation.
Yeah,
It was short and concise. And
yeah.
to the point. Yeah. Okay, let's see. I don't see any questions on the floor. Not yet, maybe.
If no questions, maybe I've got a supplies for the team. Is everyone hungry? Yeah. So I did basically like a mock-up app, right? Obviously I'm not going to send you the order, but this is an example. Like, you just scan the QR code and like submit the order. It will submit like an order to the Kafka stream, right? And I can show you how the data is come in, right? Come into Confluent, right? Just feel free to scan that QR code. And by the way, if we also have a few swag to give out as well. Later on, my colleague Ina will give the details in the chat. And if you can email her, we can send you some swag as well. So I can see the food orders. I can see a lot of orders coming in, right? Whoever ordered Hokkien Mee, right? With the food order, we'll send you some swag, right? So this is the Confluent. So one of the topics that I mentioned, right, with the displayed data streams and how we can help with that. So if you notice when you go to the order, there's also a refund. So you click refund, it will generate like a refund event. So if I do an order, I click request refund, it will generate a refund event. Yeah. You should see the refund event, and over here I can basically combine those two streams together. Yeah, I can see some refunds coming, and you can combine that order ID and the refund ID comes in together, right? The Hokkien Mee got refunded, right? So this basically with KSQL, I can combine data from multiple sources and put it into one stream of events, right? I can also find out like what are the top addresses people are ordering from. Yeah, no new message. Oh, yeah, there's one. Yeah, I can see. Okay, there's a lot of items. Well, someone is running a lot of orders on the site. Yeah. So yeah, this is just to give you a quick overview of like what Kafka can do, right? And some of the challenges that we have, the connectors, the graph database that I mentioned, like it's all, we have some connectors that are managed, some you can own self-manage, but so Snowflake, Neo4j, Mongo, you can send that data all to the different sources out of the Confluent Cloud platform. Yeah, over back to you, Teck Chun.
Yeah, right. Thank you for that. You are inviting people to BDOS your cloud using food.
Yeah, yeah.
Okay, I do have a question though. From me, how does Kafka solve the challenge of uh, those custom data processing pipelines, where it needs to go through a very structured step-by-step approach of processing the data in two different stages, and it's very brittle because the input and output needs to be of certain format, and so that the downstream modules or the code does not break easily. So how does Kafka, in your opinion, uh, solve that situation?
Yeah, I think that's one of the challenges we see with Kafka. So open source Kafka, you don't really have much. With Confluent, there's something called a stream schema registry. So it's
Okay.
basically like an API gateway. You can set what schemas you want to come in, and the data types, right? So we have that to help so the data is maintained and we can versionize the different versions of schema that comes in. But like you mentioned, a lot of the data pipelines are quite brittle, right? When you set it up, and sometimes understanding that they are quite brittle is a big, very important. So you detect those changes in the schema and then you alert yourself, or you make sure that the other party doesn't just change. If they change, then you get some notification or alert around that. With a lot of the batch processing, if it's like transactional based, it can be quite tricky. So sometimes it's better to let that be done by that system, but maybe it's a different database that is needed for that type of processing, right? Yeah.
Okay. Okay. Yeah. Another question I have is like my company we use a lot of Spark. So our data
Oh, yep.
processing is basically very Spark based. So how do you see
Yeah.
that work with Kafka? Yeah.
Yeah. So yeah, Spark works very well with Kafka, right? So Kafka streams can stream into Spark, and you can do your data processing, and you can send the data back into Kafka or to another database, right? If you've got microservices, you can scale up. So as a lot of data comes in, sometimes it's sporadic, right? You can scale up your Spark instances to deal with the stream of traffic, right? Instead of dealing with a whole batch of data set, you're dealing with events as they come in.
Mhm. Okay.
Yeah, a lot of AI ML use cases use Spark, right, and Kafka together to do a lot of processing on those data pipelines.
Right. Okay. Okay. I think one of the key other challenges is for legacy pipelines, which is quite brittle. There is already a set of tooling and instrumentation around the
Yeah, yeah,
monitoring and visualizing how the jobs flow from point to point.
yeah,
What is
yeah.
the equivalent in Kafka or Confluent? Yeah.
Yeah, I think you really need to pick apart the whole job about what is it doing, what is the presence of it. And I used to come from that background. I used to set up something like BMC Control M for
Yeah.
customers so they can visualize the job and step by step.
Yes.
So
Yes.
yeah, so we really need to go back to the basics of like what are you trying to accomplish. Like sometimes
Okay.
that can be done with the microservices architecture and having it real time stream CDC, right? So instead of having it batch, most likely they've used batch because at that time batch was the best way, right? But now with Kafka and CDC, maybe you can send it to a microservice or like Spark or a few other types of solutions out there. They can do that processing on the fly and update the views, right? Yeah, it really requires a mindset shift. Some people like they adopt Kafka, but then they still have this monthly job, and they adopt a batch processing. They load all the data for the month into the Kafka and then run this job, right? But that's not taking advantage of the new way of doing things.
Okay. Okay. Right. I also noticed in one of your challenges, I think one or two, there is a picture that shows Kafka writing to say a data lake, right, for example.
Mm.
Yeah. So how do you propose we solve for enterprise challenges where they still want to have large historians of data, lah, right?
Mm.
And from all their existing legacy systems, right? But at the same time, they want to uh, sort of take advantage of more event streaming. Yeah. So
Mm.
would that be actually the scenario that you described earlier on?
Yeah, it's quite similar. So you really need to understand what sort of historian or what sort of back-end databases they are using, right? Yeah, so then we can see how we can work. It really sometimes it's not so much about the technology; it's a mindset shift of how to do things, right? Once they have a microservices, agile, and event-driven mindset, right?
Mm.
Then you can find the right solution for it. Yeah.
Yeah. Okay. 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 I guess I don't know whether you've seen customers try to use Kafka as the conduit for ingesting different data sources into say a lake or some big data storage. Is this
Yeah.
what is your opinion of that topology? Is that the right use of Kafka? Yeah.
Yeah. I think a lot of customers do use that way. It can be quite beneficial, especially if they've got maybe traditional Oracle SQL data stores, and they want to bring that data to the cloud with Snowflake and do analytics, data bricks, and those types of solutions, right? Yeah, definitely a good use of Kafka there because it's event-driven, event streaming, and it can transform into those modern data stores and
Okay.
processing systems. Yeah.
Mm. Okay. Okay. Right. Ravindra, you got any question you want to ask? Jason? Yeah.
Yeah, maybe I just want to understand how difficult or how easy to set up the Confluent and start using it, and how difficult to maintain it for a longer run.
Oh, so with Confluent is Confluent Cloud, so it's a hosted service, right? And you can deploy it in whatever cloud provider you use. So GCP, Azure, AWS. Let's say AWS, I want Southeast one, which is Singapore, right? I can deploy a Confluent cluster inside there, right? So your existing workloads will just talk within that cluster, right? And it's very simple. Later on, I have a slide that let's see. I think that you can go in and spin up your own cluster, right? Let me share that screen with you. Yeah. Uh, yeah. If you can scan that code, you can go in and how to spin up your own cloud. There is a code as well, promo code, where you can try for new existing users for this meetup. You can try to use Confluent Cloud and see how easy it is. Setting up Kafka, you may take a bit of time. If it's on-prem, you have to set up different nodes. Typically, Kafka needs 3 brokers. You have to deploy 3 nodes for that server. But with Confluent Cloud, it's all hosted for you. It's in the cloud. It has the connectors out of the box that I showed you. So you can try this and see how it goes. We also have a Kafka Meetup group that we meet once a month. Yeah, so if you can scan the QR code, you can join us. I think we had our first physical event last week in our WeWork office in Suntec. And, so hopefully future events will also be at Suntec WeWork, and yeah, you can join us there as well. Yeah, free beer and pizza. I think I'm not sure it's the pizza, but yeah, we'll cater for something.
Okay.
Yeah. So is the Confluent also support the hybrid model as well? Like some nodes are running in on-prem and some is running in cloud, and we can able to support.
Yeah, you can run the data to collect can be on-prem, and you can send it to the cloud. But if you want like your own Confluent dedicated on-premise, we have Confluent platform. Right, that's more of the larger enterprises where they want to have the data in their own data center. They use Confluent platform. But for like digital natives, like they'll probably use Confluent Cloud, right? For setting up all these pipelines and real-time processing. Yeah.
Okay. No, I was talking about more. Let's say we have a presence in different countries, right? So,
Yeah.
say Sydney, Singapore,
Yeah.
America. So the data is being coming from those locations. So I can set up
Yeah.
a Kafka, right? Having
Yeah.
distributed in those geographical areas, and when the
Yeah.
data is coming from those region, right? Whatever is data,
Yeah.
whatever nodes are residing in those regions, right, should able to get the data over there. So it's something about an
Yeah.
automatic replication should happen so that the data can move easily, right? And then
Yeah.
probably
Yeah.
used, right? So is there
Yeah.
this kind of setup available?
Yeah. So the cluster can be accessed from anywhere, right? The reason why we let you deploy in your own your specific zone, the cloud zone, is sometimes customers have data residency requirements or they want it to be closer to their workloads, right? So you can deploy in AWS. But the Confluent that you deploy in AWS Singapore, you can have it accessible from other parts of the world as well. Like it's all connected like a cloud service. Yeah.
No. My question was that one broker, you're saying talking about 3 brokers, right? So one broker in Singapore, one in
Yeah.
Sydney,
Oh
one
no
in
no
London,
the
right?
broker is only for the on-prem. When you work with the cloud, you don't need to worry about the brokers. It's all handled transparently by the cloud
Okay.
service. Yeah,
For
you
the
just spin up the cluster. It all all works for you in the back end. Yeah,
okay.
Okay. Got it.
yeah.
Thank you for sharing. I don't see any questions from the community. Perhaps it's a slow Thursday. Okay. Right. Yeah. Noted that Confluent or Kafka has their own meetup as well. So I think the deeper questions around the platform can be taken there. And I think the community there is also quite big and vibrant. You can definitely post more detailed questions there. Yeah. Right. Um, all right. I think since there are no further questions from the community, we can sort of end today's session as well. We have also posted the link to the community at confluent.io for the swag. So just email the team there, and we'll get back to you if you are entitled for the swag. Right. Okay. I guess that's all for today. We hope to see you again very soon in June. We have another speaker lineup in June as well, likely 15 on June. Right, so we'll see you then, community. Have a great evening ahead and a good long weekend. Yeah, and thank you, Jason, again for this talk. And
Thank
thank
you.
you
Yeah,
to Lawrence.
thanks everyone.
Thank you, and thank you to Lawrence and Google Developer Spaces for hosting us. See you soon. Bye bye.